So we've talked about the different eras through the Big Bang. Now let's talk about some evidence. In the 1960s, there were two engineers working at Bell Laboratories named Penzias and Wilson. Their project was to figure out how to communicate with satellites in orbit around the Earth. This is now something we take for granted all the time, but back then this was like cutting-edge technology. Well, as they were doing these experiments, they noticed that there was a weird background noise in their microwave communications. Well, they did what any good engineer does and went through all the equipment, making sure that all the equipment was acting correct, and it did. They then realized that they were always doing their experiments during the day. So they did some experiments at night, and the noise was still there. Well, they're always pointing their receiver up towards the sky, because that's where the satellites are, so they pointed it down at the ground, and it was still there. They noticed that a flock of pigeons had begun roosting within their equipment, and maybe pigeons produce microwaves. So they got rid of the pigeons and cleaned out all the stuff, and it was still there. After doing everything they could possibly think of to try and track down where this microwave background noise was coming from, they, in the end, just accepted that it was just an inherent feature of the universe. At the same time that Penzias and Wilson were trying to track down this weird microwave noise in their experiments, there were other groups of physicists and astronomers who were trying to figure out the conditions of the Big Bang. Something that they realized is that very early on, the entire universe would have been very, very hot. So hot that the entire universe itself should have been glowing, as we mentioned previously. However, that light should get red-shifted as the universe expands, and so that light, which used to be in the visible wavelengths, should now be off in the microwave. And because the entire universe itself was giving off this light, there should be this microwave background that just exists everywhere. It didn't take people very long to realize that what Penzias and Wilson had discovered was actually this cosmic microwave background. The very first attempt to study the cosmic microwave background was the COBE mission. All this did was showed that the cosmic microwave background had a perfect black body spectrum. What that means is that the spectrum of light that we get from the cosmic microwave background is exactly what we would expect if it was light formed from a very hot object that was then stretched out into the microwaves. More recently, we had the WMAP mission, which is in the 2000s, and then the follow-up to that was the Planck mission in the 2010s. Both of these have mapped the entire all-sky view of the cosmic microwave background. And what they found is that there are very slight temperature variations, or we could say brightness variations. So in this image, this is an all-sky view of the cosmic microwave background. The blue regions are relatively cool and underdense, and the red regions are relatively hot and high density. However, something I want to point out, the temperature difference from the coolest spot to the hottest spot is 10,000ths of a Kelvin, of around 1/10,000th of a degree Celsius. What that means is, although this image makes it seem like there's a wide variation, the cosmic microwave background is actually incredibly smooth and even. Now, these slight variations in density, the low-density cool regions and high-density hotter regions, actually give the seeds for the large-scale structure. The hot regions of higher density will collapse and form into the superclusters and eventually filaments, and the cool regions will have material swept out, and those will form into voids. Another evidence for the Big Bang is actually the chemical abundance. So we know what was there, what was available during the particle era, and therefore what was available to form into the nucleus during the era of nucleosynthesis. So we know what was there, and we know how fusion occurs. What that means is we can then predict what elements should come out from the era of nucleosynthesis. And everything that we have predicts that there should be about 75% hydrogen, 25% helium, and trace amounts of lithium and beryllium. Now again, what we might mean by trace is super tiny amounts. As we look at primordial clouds, these are parts of the interstellar medium that have had the least amount of influence from stars. This is exactly what we see. And if you remember, as we've talked about almost everything in the course, the universe is about 74% hydrogen, 25% helium, and 1% metals. That 1% metals that is off from the 75% hydrogen, 25% helium has come from stars. So even the chemical abundance of the universe matches what we expect from the Big Bang Theory.